But now we'll get to our speaker, Emily Zabor, at the Cleveland Clinic. We're really happy to have her here, and she's going to tell us all about making cool tables using this package called gtsummary. So go take it away, Emily.
Great, thanks for having me. And I'll just start by apologizing for blinding everyone with this sunbeam coming in behind me. I found as seasons progress, there's all these new times of day that I have to shift my head to block the sun. I don't have curtains back there. So hopefully that'll pass quickly. But thank you for having me. I'm going to be talking about creating presentation-ready summary tables with gtsummary today. But since I'm new to this group, I am going to just tell you a little bit about myself before I get started. Started my biostatistics career in Minnesota, got my master's degree from the University of Minnesota, 2010. And after that, moved to New York, where I worked for 9 years as a research biostatistician at Memorial Sloan Kettering Cancer Center. And I'd been programming in R that whole time, but that was when I really got involved in the R community. So I was a founding board member of the R Ladies New York City chapter and was involved in the New York R group and also the New York R conference while I was there. And during that time, I also was working part-time on my DR/PH degree in biostatistics at Columbia University. That's a Doctor of Public Health degree, which I finally finished in 2019 and then moved to Cleveland to join the biostat faculty at Cleveland Clinic. So I moved here just over a year ago and have been working at the Cleveland Clinic in the Department of Quantitative Health Sciences and in the Taussig Cancer Institute. So I'm still doing cancer biostatistics. So I'm going to give you a little background on the gtsummary package and the motivation for its development. And most of this I'm going to be kind of couching in my own personal experience, which is working as a cancer biostatistician and in medical research. And throughout this talk today, I will be kind of focusing on examples that have to do with medical research, but making reproducible tables is a topic that is applicable to many fields and people working in all sorts of different fields. So I think you'll be able to find something useful for you in here today, even if you work in some very different area than medical research. And just before I go much farther, feel free to interrupt with questions as I go at any time. I'm happy to take questions. So really, this package was motivated by the reproducibility crisis in science, which there is wide agreement among scientists and researchers that there is a reproducibility crisis, either a significant one or a slight one. The quality of medical research is often low, and sometimes that's due to low quality code. And the editors at a journal I am involved in, European Urology, which is a clinical journal about urology, did a survey of researchers who had non-trivial statistics in their papers asking about the code they used. And we found that a third of them didn't use any code at all to produce those non-trivial statistics. And so, this is kind of a huge problem in medical research. And low quality code is more likely to contain errors. Reproducibility is the key to fixing some of these problems, but it can often be cumbersome and time consuming. So for people who don't have programming experience or clinicians, we want to make this as easy as possible. So this is just an example of a very common table you would see in a medical research paper, a table 1, which is just down the rows, you have characteristics of the included subjects, and in the columns you have some, outcome of interest, and then maybe a column of p-values like this. And what we wanted to do, developing gtsummary, was get a table that looked as much like this as possible out of R without having to touch it, without having to touch the words, the numbers, the formatting, the lines, the bolding, nothing, so that we could reduce errors in these tables as much as possible. So we discovered that some of us in the Department of Epidemiology and Biostatistics at Memorial Sloan Kettering, we had all kind of come up with our own little solutions to this and our own little pieces of code for how to do this, and none of it was very good. So we got together and started working on an internal package that at the time we called BiostatR, which was on our internal MSK GitHub, and we all started using it and we started training the rest of our department in it. And over time, we decided that it was so good that we converted it into the public package gtsummary. And so now it's out there. It's available for all of you to use, and hopefully you'll find it useful. So gtsummary is a package that is specifically made to create tabular summaries. It has sensible defaults, but is also highly customizable. And the main types of summaries it makes are table 1 type summaries, like I just showed the example a couple of slides ago, basic cross tabulations, summaries of regression models, summaries of survival data, including median survival times or survival estimates at specific time points. All of these types of tables are also available for survey data. And then there are custom tables available. It's possible to customize for any type of table, but not any type of table, but a lot of types of tables you might want. You can also report statistics from gtsummary tables inline in R Markdown, which I'll demonstrate. And then you can stack and or merge different table types as long as they're compatible. There are themes available to set defaults for all of the tables in a single report. And you can also choose from different print engines for producing reports. And this is also kind of an outline of the pieces of my talk today. So I'll go through all of these in more detail. So before I get into the details of the functions, I'm just going to introduce a data set that I'll be using throughout the examples. It's the trial data set, which is included with the package. It's a simulated data set in the context of a clinical trial. So it includes baseline characteristics of 200 patients who are randomized to receive either drug A or drug B. And the variables are labeled in the data using the labeled package, which is a great package for labeling variables. And I'll explain in a little bit why I'm mentioning that and why it's important. So here's just a printout of what the variables look like. Treat is the treatment variable, age is the patient's age at baseline, marker is like a continuous biomarker of some sort, generic biomarker. Stage and grade are both cancer variables, categorical, that have to do with the severity of disease. Response is an indication of response to treatment. It's binary, 0 for no response and 1 for response. Death is also an indicator of whether or not the patient died, binary variable. And then the TT death is the time to death or censoring. So I'll actually be using a subset of these variables for most of the tables I'll be showing today, just the age, grade, response, and treatment. And I've just shown here the variable names and the labels of those variables. So I'll be focusing on those just to give examples. So there are really 2 main functions in the gtsummary package, table summary and table regression. So I'll go through the details of these 2 because they're both like very powerful functions for creating nice tables. And so first I'll go through the details of the table summary function. Some might say this is pronounced tibble summary, but I still say table. It's a little old-fashioned. So this is an example of just a basic table summary output with no arguments to the table summary. So what I have here in my code is just our selected variables from the trial data set, and I'm actually also selecting out the treatment variables. So we're just going to see age, grade, and response. And then you just pass a data frame to table summary and you get this table. And the most basic table gives you down the rows, the names of the variables, and you can see that it uses the labels if they are there for the variables. And the numbers in here, the basics are the median and IQR is the default for continuous variables, and then N percentage is the default for any dichotomous or categorical variables. And any variable coded 0, 1, true, false, or yes, no is treated as dichotomous. And so only the 1, true, and yes is printed on a single row of the table by default. And you can see also that NA values are printed as a row listed as unknown below the variable name. And there are 3 main types of summaries: continuous, categorical, and dichotomous. But actually this changed as of the CRAN release that came out yesterday. And so I have some bonus slides at the very end discussing a 4th type of summary. So I'll add that in when I get to it. Had to tack it on to the end. I didn't have time to go back and incorporate it. So yeah, some of the main features, as I already mentioned, the label attributes are printed automatically, and these are the defaults. We get a little footnote saying what the statistics are, and that will change if you customize those. So there are a variety of ways to customize table summary output. The main ways are using arguments within table summary, and then there are add-on functions, which I'll discuss in a minute. So I'll go through some of the arguments to the function itself. The by argument would make a column variable. So here I'm saying by treatment. So now I have columns for the drug, the treatment column for drug A and drug B. Statistic lets you customize whatever statistic is reported. And I'll discuss in a little more detail, I think on the next slide, how the syntax for making arguments to all of these different arguments, but the basic style is to have the name of a variable and then something that you want to do to it. So here I'm saying that I want to use the sample size over the total sample size and then the percentage in parentheses. And we use syntax from the glue package for all of these ways of specifying different statistics. And so you can see now down here for the tumor response variable, instead of just having the n and percent, which is the default, I have the n over the total sample size and then the percentage, which I had specified here. You can also specify labels for variables directly in the call to table summary. So if you don't have variables labeled in your data frame, you can specify them right here. Or if you just want to change one, I've changed this from tumor grade to pathologic tumor grade. And then you can also say how many digits you want for different variables for rounding. So I've made age have 2 digits. It was a whole number, so I just have a bunch of zeros added here now.
Emily, quick question.
Yeah.
If you wanted to customize more than just like, so each one is just affected one. If you wanted to affect the statistic for the response and the age, does it be like a list, or how do you do?
Yes, it would be a list. You can just use regular list syntax and put as many variables as you want. And I'll go into some more details of how that's done in a couple of slides. Yeah, great question. Actually, one slide, here it is. Okay, so the basic way that
sorry to do that to you.
Yeah, exactly. No, it's perfect timing. So the basic way that you specify arguments to table summary is you provide the name of the argument, an equals sign, then you select variables, you use a tilde, and you give it instructions. And we do have functions that are tidy select style functions. So you can select all continuous, you can use starts with, ends with, contains, all of these different tidy select functions are supported, which is really convenient. But you can also list individual variables that you want these different things to apply to, like I've given an example of here. So those are arguments to the table summary function itself, but now we also have add-on functions, and these are sort of things you do after the fact. So you create your table and then you're doing more customization to it after the fact. So there are 3 basic classes of add-on functions. There are add functions, which add additional columns of statistics or information, modify functions, which can modify different parts of the table, like the headers or the formats of the footers. And then there's bold and italicized, which does exactly what it sounds like they do, to style labels or levels or bold significant p-values. So I'll show examples of some of these. So here I've used 2 different add functions, add p, which adds the column of p-values. And you can see a new footnote has also been added to the bottom saying what statistical tests those correspond to, which the defaults are the Wilcoxon rank sum test for continuous variables and the chi-square test for categorical variables. Or I think it calculates the expected cell count, and we'll use Fisher's exact test if that's more appropriate. But you can change any of these tests with a call to the test argument inside add p. There are a variety of other things you can customize there. And then I've also added a column of q values, which are p-values that were adjusted for multiple comparisons, with just a call to the p.adjust function. And the default is false discovery rate adjustment, but I've specified here to use Bonferroni. And you can see also an additional footnote's been added saying that that's a Bonferroni correction, which you would never want to do in this specific table. But for example, if you had a bunch of gene mutations that were by another variable, you might want to add a column of adjusted p-values to a table like that. So here I'm showing a few other options. Add overall adds a column of overall statistics. So in addition to having the column by drug A and drug B, we now have for the whole cohort. Add n puts the sample size for each variable. So this could be used in addition to or in place of having the row of unknown variables. So here I've actually suppressed the row of listing the unknown number, and I've replaced it with a column with the sample size, which kind of gives you a sense of how many are missing for each variable. And then add stat label. Instead of having the footnote saying what statistics are presented, these have now been appended to the variable name. So it says age, comma, median IQR, grade, comma, number percent. The default is to say n%, and I've just customized that to say that I want the label for all the categoricals to be no.%. And there's a bunch of customizations for all of these that you can see in the help files. I couldn't possibly go through all of them, so I'm just showing you some basics here. So we can also bold or italicize both the labels and the levels of the variable. So here I've bolded the labels. So we see the age, grade, and tumor response are bold, and I've italicized the levels. So if you have if you have an unknown row, that would be italicized, or the levels for a categorical variable like the 1, 2, and 3 for grade have been italicized. We can also bold p-values according to a threshold. The default threshold is 0.05. We didn't have any significant p-values in this example data set, so I set a threshold of 0.8 here just to show you how that bolding would work. And you can do the same thing with the q values to bold them for a significant threshold. So the modify functions can modify different parts of the table. Here I'm going to modify the header first with a call to modify header. And I'm using a list to modify the name of the drug A and drug B columns. And I'm calling stat_1. I want to just name it A, stat_2. I'm going to name this B. And then I'm additionally going to modify the spanning header, which is the header that spans those columns, and call it drug. So instead of having a single label that says drug A and drug B, I now have drug across this column in A and B. And we do have a function available called show header names. So if you create a table, if you create this table up to like this parenthesis here, and then pass it to show header names, you'll get out what these labels are so that you know which ones to modify, because they're not necessarily obvious that stat_1 is the first column and stat_2 is the second. So there is a way to see what those column names are. And I've also modified the footnote just to change how I'm presenting the the label for the statistic. Instead of saying statistics presented, it just says median IQR for continuous and n% for categorical. And you can modify these in any way you want. So that's just an example of some of the ways to modify different pieces of this table to customize it as much as you want. And there are many more available. I've just shown some of the most basic ones. There's great documentation at the package website, which I've put a link to here, and also detailed vignette for table summary that's available on the website. And I've linked to that here as well. Any questions about table summary before I move on to one more slide in the table summary section? Well, there's one more function that is related to table summary. It's table cross, which is just a wrapper for the table summary function, which is specifically for n by m tables. So if you just want a single row variable and a single column variable. And so it's a little bit different. Instead of passing a data frame, you will actually state what row variable you want, what column variable you want, and then how you want the percentage calculated. So here I'm going to calculate row percentages, and I'm saying I want the margin to be on the row, which adds the total column down here across the row. And so if I said margin on the column, I would get a total column over to the right of the grade. And now there's this additional option when I add P, I say source note equals true, and it puts the P value down in the footnote instead of adding an additional column, which is kind of nice for a simple n by m table like this. So the other primary function in the gtsummary package is the table regression. And this is for summarizing regression models, which is another really common thing we do in medical research, but I know a lot of you probably do that in other fields as well. So I'll just start out by creating a basic model using GLM. I have my outcome as the response, the treatment response, and two predictors, age and stage, from the trial data. And I'm going to use a logit link. So this is a logistic regression model. And we've all seen this before. If you summarize this model, This on the right is what you get. It doesn't look great. It has a lot of extraneous information. It's very hard to see, and you wouldn't really want to share this with anyone else or print it into a report. So table regression with no other arguments, just passing the model to it, goes a long way to getting us something that's what we want already. So this is the basic output from table regression. It gives you your variables down the row, and then your estimates, a 95% confidence interval, and the p-value. And so this is already a great start. It gets rid of the extraneous information and gets us, a nice looking table. So now we can add some different arguments to it. By saying exponentiate equals true, we get odds ratios instead of log odds ratios, and also the 95% confidence intervals for the odds ratio. And add global p, which is an add-on function for table regression, gives us the global p-value for t-stage instead of those level-specific p-values that we had on the previous slide. So we just have a single p-value now for t-stage, the association between t-stage and response. There are quite a few models supported in table regression from the STAPS package, LM and GLM, from the survival package, CoxPH, CLogit, and ServReg, from LME4, Glimmer, and Elmer, and from GEPAC, GEE, GLM. But basically, any model that you can tidy with the tidy function from the Broom package, you can pass to table regression. And so it's pretty easy to write a custom tidier for a lot of models that aren't supported by the Broom package. And if you write a custom tidier, you can pass it to table regression using the tidy _ fun argument. So really almost any regression model can be supported. And we're starting to put together a suite of custom tidiers, and a couple of them were included in the release that came out yesterday, but I'm not going to go into details of those today. But if you can tidy it with Broom, you can pass it to table regression. It's also possible to do univariable regression results. So what I showed before, if you just had a single variable, it would work. Table regression would work fine. Or if you have a multivariable model, table regression is what you want. But a lot of times we want the univariable regression results for a number of different variables. And so you don't want to have to call table regression multiple times for every single individual variable. Instead, what table UV regression does is it takes some different arguments. So you have to specify the method, which is the type of model you want to fit. And then you specify your outcome variable, y, with the argument y. In this case, I'm saying I want the response to be the outcome variable. And then it takes every other variable that's in your data frame and treats it as a predictor in a univariable regression model. And it fits all those models in the background for you. So you can specify different arguments that would get passed to the method that you're using. So here in method.args, I've said that I want to use the family equals binomial. You can use a list to specify multiple arguments that these get passed directly to GLM. And then again, I'm saying that I want to exponentiate these. And so this is a really nice way to be able to get univariable regression results into a table for multiple variables without having to even fit the models yourself or to pass a bunch of table regression calls. So you see what we get here is similar to what we had before, only these are univariable results. We have treatment, age, and grade down the rows, and we have our univariable logistic regression results. And this supports survival models and linear models and all of those other models that I already mentioned. And there's some examples of how to put the syntax into the method and how to specify the responses on the help pages. So you can see how that should be specified.
A quick question.
Yeah.
Can you hear me? Yeah.
Yes.
This table could just be easily misinterpreted as a multivariate regression output. If you were just looking at the table, there's no hint that it's a bunch of separate regressions.
Yeah, that is true. That's a good point. The only thing that is a tip, and I only know this because I am familiar with the function, is the only difference in how this output looks to the table regression is that there's a column of sample sizes, which are different for the different variables, since each one can have missing values a different number of missing values, but I wonder if we should add a footnote to this to make that clear. That's a good point.
Okay.
Any other questions? So of course, in our Markdown, it's possible to use inline text, which is great. And our reports and tables take us a long way towards what we want, but we often need to write paragraphs of text as well. And this is supported in our Markdown, and we have added a specific inline text function into the gtsummary package so that you can grab specific parts of your table and report them directly in line without having to customize that. So any statistic that's reported in a gtsummary table that you've made can be extracted and reported in an R Markdown document using the inline text function. And you can specify the pattern argument to inline text to say what you want, how you want to format that statistic in the inline text itself. So for example, this is what the syntax looks like for the default pattern for a regression table. It gives you the estimate and then the confidence level times 100 with a percentage. It says CI, and then you get the p-value after a semicolon. So that's the default pattern, but you can specify any type of pattern that you want. If you just want the estimate, if you want to say odds ratio equals before the estimate, and this is again using glue syntax, which is what the package uses throughout. So for example, if we had this table of regression estimates, it's the same syntax we use for any inline text in an R Markdown report, where you have the \r, and then we call the inline text function and we say the name of the table. So this is what I've called the table object is m1_table_2. And then I'm saying that I want this for the variable age. And this is just the default arguments to inline text. I will get this printed out. The odds ratio for age is 1.02, and then in parentheses, the confidence interval and the p-value. So it's a really nice way just to grab things from that table and include them in line in your R Markdown report. So we also have functions available to merge or stack different tables, which is something that we often want to do. So table merge is for side-by-side tables. So for example, if we wanted to make a side-by-side table of univariable and multivariable regression results from a Cox regression model, we could create our univariate table here on the left. We select the variables that we want and we pass them to table UV regression. We specify the method as Cox PH, and our outcome is a serve object with the TT def and def, and we're going to exponentiate those and add the global p-value. And then on the right, we have our multivariable model, which we fit with Cox PH and pass to table regression, and again, exponentiate the results and add the global p. So these are the two individual tables we get. We have the univariable results on the left, which the only difference is it has that column of sample sizes, and on the right is the multivariable table. And now using table merge, we just pass a list of the names of the tables. So I saved the univariable table as this first object name and the multivariable as the second object name. And then using the tab spanner argument, we can say what text we want to go above the results from each of those tables. By default, it just numbers them in order. So if you didn't specify anything to the tab spanner argument, you would get table 1 over the first object you pass to the list and table 2 over the second object you pass to the list. And there can be more than 2. It can be 3, 4, however many you want to combine, and it would just number those in consecutive order. But here I've said that I want them to be called univariable and multivariable, and this is the result you get with those columns combined, and it has the single row for those common variables. And it won't work if you don't have the common variables between the two tables. So it only works under certain conditions. And then table stack combines tables vertically, which is something that you might want to do. For example, if you wanted to show the results for a single variable from an unadjusted and an adjusted model. And so here on the left, I've created a univariate model for the treatment effect on survival and pass that to table regression. And I've I didn't need to have that in there actually, but it's fine. I've labeled this and I've exponentiated it. And then on the right, I have the adjusted model. So it's the treatment status and then adjusted for grade and stage and marker. And I passed that to table regression. And in this case, I did need to have the argument show single row equals treat, which means that in this multivariable table, I'm actually only going to show the row for treatment. So these are the results from those two different function calls. So on the left, I have the unadjusted model for the treatment effect. And on the right, I have the adjusted model for the treatment effect, which was adjusted for those three other variables. And so now I'm going to use table stack to stack these vertically. And again, you just pass the tables with a list. And similar to tab spanner, now this has an argument group header, which puts the header above on the row above each model results. So I've said unadjusted and adjusted. And again, if you don't specify this, it will default to just numbering them table 1, table 2 in the order that you pass tables in that list. And so it's kind of a nice way to stack up different regression results. And in this case, you wouldn't have to have common rows. You can stack tables with different row variables if you wanted to for some reason. But as someone mentioned earlier, you would want to be careful about what results you're presenting here, because at this point, the table's not really telling the person looking at the table what's in here. You have to tell them. So there are themes available in gtsummary that can allow you to set your own defaults for all the tables throughout your report, and you can change these as you go as well. So a theme is just a set of customization preferences that can easily be set and reused, and they control the default settings for existing functions. So the themes control the more fine-grained customization that's not as easy to use through arguments and helper functions. And so there are a number of themes that are available in the package, but you can also write your own. And so I'll show you some of the available themes and then also an example of how to create your own theme. So this is the tables that you've been seeing already throughout this presentation. It's the default theme. You don't have to do anything to get this. And I'm just showing up here at the top of my R code, the function reset gtsummary theme. If you want to have multiple themes throughout your one document, you would need to use this to clear the previous theme, or if you just want to go back to the default theme. So there are a couple of journal themes. This is really only relevant for people working in medical research, but there are themes that are specific to the Journal of the American Medical Association and the journal Lancet. So those journals have specific formatting requirements for tables submitted to their journal. And so this is a nice way to just get all of your tables in your report formatted specifically for either of these journals if you were planning to submit there for publication. So you can see using the JAMA theme, we now have dashes inside our IQRs instead of commas, and the percentage sign has been removed from the back of the percentages. So these are just, and all of p values have 2 decimal places. So these are just specific to that journal. And we just set this theme by calling theme gtsummary journal and saying journal equals JAMA. And right now there's only those 2 journals available. There are language themes available that you can get through theme gtsummary language. As you can see, the translation is hit or miss for these. This is what's available through, I think, GitHub languages. But I've listed the language options down here and just on the right showing an example with the Hindi translation. There's a compact theme, which reduces padding and font size. So you can call this with theme gtsummary compact. And then you can customize your own theme. So here I'm going to create my own theme, and I'm going to specifically customize some of the GT parts of this table. So I'm going to make the font size smaller, and then I'm going to add a custom title and subtitle to all of my tables. And I'm going to add a custom source note at the bottom of each of my tables. And I'm going to remove the lines from the middle of the table, and I'm going to use row striping instead. So like every other row will be filled with gray. And so I'm creating this theme called My Theme. And I'm just going to show you, you can see here some of these arguments I've used are called like user_added1. So I'm just going to show you how to find out what to use for those. If you create your table, so here I've made a table called returns, and the last row here, I've piped to as GT and said return calls equals true. If you then print out that object, you'll see what the names of these arguments need to be. So you don't have to guess at those either. So that's just a way to see how to customize these different arguments. So now I just use set gtsummary theme and specify my theme. And this is what I get. I get my table where I have my custom title, Emily Zabor's table for internal use only as my subtitle. And as you can see, I have this like zebra striping now and my source of my very private internal data, the footnote at the bottom. So any customizations like this are possible. There are tons of options, and I've linked to the vignette on the themes here where you can see the different ways to customize these tables so you can create your own theme to use throughout your tables. So there are a variety of print engines available to use with gtsummary, and here's a nice little table from the package website showing these different options. So you can use the print engine GT, Cable, Flex Table, Cable Extra, Huxtable, or Tibble. And you can see here, there's some of these different output types, the HTML, PDF, RTF, and Word are supported differently by these different print engines. And so depending on what you want to use, you might get better or worse results. The results in HTML just tend to be the best, but if you need to use Word, you can see that some of these different print engines will support that better than others, and same for RTF. And I'm just going to show you some example reports now to see what these different print engines look like when you use them. So I've put links here, but I've actually have these open. So I think that this changed. Can someone give me a thumbs up if you see a different window now? Yes, awesome. Just making sure I didn't accidentally only share that
it's working,
one on
yes.
tab. Perfect, thank you. So this is just an example of a gtsummary report. So I've run an R Markdown report on this, and I'm going to show you each of the different print engines. So I've just made a single example table, and this is what you get if you use the GT print engine, the Cable print engine, the Flex Table print engine, Cable Extra, Huxtable, and then Tibble doesn't format at all. So I don't even know why we include that as an example, because it doesn't format in any of the output types. So you can see there are a lot of differences in how these tables look depending on what print engine you use. And so we have written the package to be a companion to GT. And so all of the examples I showed you before this were GT, which will be the default unless you change it. And so if you want to change the print engine, you will have to specify that at the beginning of your R Markdown session or as part of a theme. Let's see if I can get to this next. There we go. This is the PDF example. So if you want to make a PDF report, it looks really nice. The GT looks nice, but you can see that the footnote has kind of shifted to the left a little here. So that's not great. When we use Cable, the footnote's gone completely. Flex Table does a pretty good job in PDF output. We have our nice footnote here and it's in the right place. Cable Extra is not really formatted. Huxtable looks okay, but some of these footnotes, we've lost our little subscripts here. And again, Tibble doesn't format at all in any of these options. I don't know if anyone ever makes an RTF output report from R Markdown. But here's an example of what that would look like.
There are literally ones of us.
So it does okay with GT. Cable, not too bad, but you don't get your footnotes. It does not support Flex Table or Cable Extra. Huxtable looks pretty good. And again, Tibble is just completely unformatted. And then the last is Word. I actually make a lot of Word reports specifically because clinicians love to copy and paste their tables straight out of Word. So I know this is not popular, but I actually do this a lot. So I'm particularly fond of the options available for Word. So it does not support GT, which is the default print engines. You cannot use that in Word. Table does okay. This will be the default if you use a Word document, but I actually think Flex Table looks the best in Word. This is really a very nice package actually that prints tables really nicely in all of these output formats. I think Flex Table does a great job. Cable Extra is not supported in Word. Huxtable does okay. And again, Tibble's just a Tibble. So those are the different print options for print engine options for gtsummary tables and some examples of what those look like. So you can come back to these links. I have the code for each of those reports and also the output linked here on each of these slides for each of the output types that you could reference in the future if you're interested. So just going to wrap up, and then I have a few slides tacked on at the end for about the release that came out yesterday. The gtsummary website is excellent. It has a number of vignettes about the main functions and features. So definitely take a look at the website, which I've linked to here. And to install gtsummary, it's available from Crayon, so you can install it in the standard way, or you can install the development version from GitHub. And actually, this plot that I have here of Crayon downloads only goes through August, but we passed 5,000 downloads in September this month. So new milestone for the package this month. Have to include that next time. And then just a thank you to the authors of this package. Dan Soberg at MSK is the maintainer and the primary author of this package, along with colleagues Margaret Hannum and Chrissa Whiting and myself. And then a number of contributors from both inside MSK and outside. And just a special thanks to Dan and Margie, who I borrowed some materials from for this presentation. And I've put my contact information at the bottom of this slide, Twitter, GitHub, and my email address at Cleveland Clinic. If anyone wants to get in touch or ask questions about any of this, feel free to do so. So as I mentioned, there was a new Crayon release that just came out yesterday. And so I wanted to add a couple of tidbits from this. I'm not going to go through all of the new features, but just quickly, there's a new summary type. That's the biggest new feature. It's called continuous 2. And the reason it has the 2 is because it prints a continuous variable on 2 rows now. So you can see here, I'm specifying I want age to be type continuous 2. So instead of having the summary on the row that says age, there's a new row added that says the type of summary and lists the output of that. And with that, there's a new companion selector function, all continuous. So here I've said, I want all continuous 2 variables to be the mean and standard deviation by default, which is only age in this table. So instead of getting the median and IQR, I now have the second row with the mean and standard deviation. I guess this is a common thing people want to do, though I personally have never wanted to do this. So, but got to give the people what they want. So there are a variety of there's also a theme available that will make all of your tables default to continuous 2 for continuous variables, if that's what you want. And there's a new function added that is called add glance source note. So this has to do with the glance function from the Broom package. If you're not familiar with it, if you fit a regression model, like this example GLM regression model, if you pass that to the glance function from the Broom package, this is what you get. It's a variety of those. It's a clean, tidied up version of some of those extraneous pieces of output that aren't the regression coefficients. So you have your deviance and your log likelihood and the number of observations and degrees of freedom and all of that. So we can now add this as a footnote to our regression table. So if I make a table regression, I can pipe that into add glance source note. And what I would get by default is all of those pieces of information printed in a footnote now on this regression table. But there's an argument to this function where you can select individual pieces of this by their names that are in this default output. And that's all mentioned on the help page. So you probably wouldn't want to print all of this, but maybe you just want to include the AIC or something in a footnote of your table. So making that additional piece reproducible in these R markdown tables. And there's more. I've linked to the news item for this newest release of the gtsummary here. So please check it out. And that's all I have. Thank you.
Cool.
Thank you.
Mm-hmm.
Yeah, this is super awesome to me because I spent so much time this summer doing exactly this kind of stuff.
Yes.
And I even went so far as to like make a wrapper function for the table 1 package to do some of this, but maybe I'll just abandon that and pick up your project. I do have one question though, because you started your talk with talking about the reproducibility crisis. And I'm curious, like, you know, this seems like it's going to reduce some of those errors, especially in like table 1s. But to me, that's not really like the reproducibility problem that I see. I feel like a lot of the problems have to do with the pre-processing of data and things like that, and not as much you like transcribing things incorrectly or like presenting them in kind of a funny way that's confusing to people or something like that. So I don't know what you think about how this actually affects that reproducibility problem.
Yeah, that's a really good question. I think the reproducibility crisis is multifaceted, and there are a lot of pieces of it that we as analysts or statisticians can't necessarily control. And so pre-processing of data, maybe we have a little control over that. How the study is conducted, maybe we are involved in the design stage. But a lot of times, you know, the science that's going on to produce the data and those designs of studies, we're not always consulted. And so this is just kind of controlling our little piece of the reproducibility crisis, the numbers, and also making our lives easier, because I know this is very common and has been in my experience. You know, I finish, they're like, here's the final data, and I produce a whole report, type up all those little numbers, and then I send the report, and 2 days later, okay, here's the final data. I changed this one number or whatever. So in this way, you know, if you use our markdown and have these table functions and inline text, so you're not typing any of those numbers, it goes a long way towards reducing those errors that we're making as analysts and statisticians when we're typing out individual numbers or transcribing things. So you're absolutely right, it doesn't solve the scientific side of the reproducibility crisis, but I think in terms of writing reproducible code and making it so that it's easy to make updates if the data do change or if more patients are added and that sort of thing, this is a great step towards that.
Presumably, you know, in terms of reproducibility, you know, you would separate the presentation layer from the data layer anyways, right? So it's like, because I always used to be a clinical data manager, it was always the same way, right? Here's the final data, and then like 3 days later, it's like, no, change it. You know, so presumably, you know, what I used to do anyways is, you know, you have your analysis script that would burp out like a R data file at the end that has all the final stuff, and then you have a completely separate, you know, thing that makes it pretty, presentation script. And so the nice thing is, you know, you can separate them, and then you just feed new data through that sort of process each time, right? And so I do think that does a lot in terms of, yeah, maybe it doesn't solve like, you know, the hacky, you know, 19 pre-step process, right? But it does prevent, you know, sort of the sort of low level, like, oh, I copied it wrong. And more importantly, I think it saves a lot of time for the people who need to spend more time on pre-processing, who never have enough time because they have to copy and paste a bunch of little numbers into a Word document every 2 days. And so I think it adds a lot of value in that sense too.
Yeah, I totally agree with that. And, you know, before I was using this as my workflow, where I, you know, had completely reproducible R markdown reports, where I never, you know, type out a single number in those. I always program every single number that comes out. It wasn't just me, I was touching the numbers, but then the investigator was touching the numbers again to format the tables even nicer, you know. Mm-hmm. And so there were these multiple levels of possibilities for mistakes, and that I did have mistakes happen. And so I think it helps.
Yeah, those are great points.
Yeah.
Hey, Emily. Sorry I joined late, but it's nice to see you.
Hi, nice to see you too.
And thanks for building this and all of the effort that was put in. As was said, so many hours of 5,000 people who are saving hours now. Just a comment on the reproducibility. I think for me, switching to Markdown, and the more I switch to it, the fewer kind of one-off tables I would send via email, and just have a folder with like analysis. And then if the data changes or if something changes, then we have analysis 2 and analysis 3, and you can keep track of your versions. And at each time you have your entire set of analyses for that given data set and for those chosen analysis. And that's gone a really long way from, hey, I got this plot from you, like, where did it come from? Or how did that kind of come together? Just keeping it all together and everything always all together has saved a lot of time.
Yeah, I completely agree. And I have a similar way of doing things. Any other questions or comments?
Are there any situations in which you have found this package to display something, I guess, I don't want to say incongruent, but you expect it to, with the particular model type or a particular something in a situation where like you would expect it to be, I don't know, the confidence interval, but it's the IQR. Not that that would be the case, but.
I haven't had that happen yet. Definitely there have been a couple of types of models that I've tried to use that haven't been supported. And so I've had to get around to that. But for the most part, my experience has been that it works as expected, as long as you know what to expect. But we would definitely want to hear about any times when that's not the case. So please go to GitHub and report any bugs, because that's definitely something we would want to know about.
Have you ever been reading a paper and be surprised that you see a table and you think it was made with gtsummary and be pleasantly surprised?
Not yet, no, but I would love to see that and know.
Is it distinctive enough? Can you tell? Like, you can tell a ggplot2 plot. Like, you guys have to leave a little watermark in there or something.
I guess, journals do kind of put their own formatting on top of things when they typeset. And so you probably wouldn't be able to tell in that case, but maybe I would be able to see it in a presentation or something. So I'll keep my eye out.
What would really help with reproducibility is if journals laid out their articles in Markdown, right? Because then you have to submit the data in order for them to make the paper. But that's probably a bridge too far right now.
I mean, that in medical research, you have too many HIPAA problems when it comes to sharing data. So, reproducibility is only ever going to get so far when you're talking about clinical patient data, because data sharing is just a huge problem there for patient privacy. So in other areas, I think maybe you can get a little closer to that. But when it comes to patient privacy, which is better protected, it's hard to get around that.
Yep.
Just from experience, I have to say that's generally the case. And I've written a lot of papers and books in the math field and stats over the last 20 years. And every single one has either used LaTeX or Sweeve, and has been the final formatting was applied by the publisher.
Right.
So I wasn't in control of the what you would call, and the cool thing about Markdown is it's brought that concept of Sweeve into other realms like Word and HTML. But in most fields, that's been the case already now for decades. The fact that you've completely separated, as someone said earlier, presentation and computation and data.
Yeah, definitely. And we'll never be able to stop that. I still, when my papers are typeset by the journal, I still double check all the numbers to make sure that they got them right, which I don't know if you can ever. I don't stop doing that. You never know.
All right, any final questions? Horror stories about publishing? I will save everyone from my Word document escapades that journals require. Fortunately, the biomedical journals are not like the math journals.
yeah, I'm appreciative that some of these things render in Word too, because I'm forced to do that as well. And
Yeah.
I don't like it, but I have to do it. So
Yeah, I agree. I use a lot of Word.
So I do have one follow-up question about that. As somebody who's been using Sweeve for decades now and LaTeX, I really appreciate all the new R Markdown style things that are happening, and many of these kind of nice uniform, Broom in particular is a brilliant idea to uniformly present the output of models. But I get the sense often that a lot of these things are geared for only these new technologies, and they forget about Sweeve and LaTeX, and they don't really support. I mean, for example, your tables, that was not an output option for any of your comparisons for any of the table rendering engines, for example. Is that just because only it's such an anachronistic thing and only old people like me are using that stuff these days, or I don't know.
Yeah, I mean, yes, I think our Markdown syntax is so much easier to write than Sweeve that I don't think anyone is learning it anymore, I have to say. And you can produce PDF output. I did show an example of PDF. So that is rendered in LaTeX. You do have to have a LaTeX installation on your machine in order to knit a PDF from our Markdown as well.
Yeah, I was gonna say, I think the thing that happened is that I wrote a fair amount of Sweeve several years ago. You know, LaTeX is just like R Markdown, forget R Markdown, just Markdown in general exists because LaTeX is cumbersome for everyday use. And that doesn't mean it doesn't have its place, right? You know, I used to tell students something that a physics major told me once, which is, you know, Windows makes 90% of the stuff easy and 10% of the stuff impossible, and Linux makes everything medium hard. LaTeX is that for typesetting, right? Like Word does 90% of the stuff fine, and then there's 10% of the stuff you just can't do, right? Same thing with Markdown. Whereas with LaTeX, you can do it all, but the trade-off is like, it's like a lot more complicated. And so, you know, I don't think that's changing in like physics, right? You know, where people get the equation, you know, formatting, you know, and the way to lay out math equations, right? You know, I don't think it'll ever go away necessarily in that space, but I don't know, the more you sort of drift away from needing to do a lot of equation heavy, like arranging in your paper, I think the less likely people are to be like, oh yeah, I'm going to definitely reach for LaTeX for this.
But why wouldn't this stuff should all work with Sweeve, shouldn't it? I don't. What was our Markdown specific about it? I think you should be able to put this stuff in a Sweeve chunk, right? Did I miss something?
Yeah,
I don't see why you. Yeah, I don't see why
Okay.
you couldn't. I've never tested it.
Yeah, I guess I should try some of these things out. Yeah.
Yeah, I don't see why it wouldn't work. And I think that the output would look just like it did in my PDF example that I produced knitting in our Markdown document. So I think that it would work fine. This talk was specific to our Markdown because that's what I use. I have used Sweeve in the past, but I kind of forgot about it until you brought it up.
I came in late, so I was looking through the slides, and this table cross function just changed my life. Doing a cross tab in R is so cumbersome and complicated, and I have such ugly code to do it. So thank you.
Good.
All righty. Last chance. Okay, thanks everyone for the great discussion and questions. Thanks again to Emily for talking today. And I want to remind people, so we have our talks through the end of the year, but 2021 is wide open. So all those people introduced yourselves, all the different things you're doing. If you want to do a talk, you can do a 45-minute one, or if you just want to do 20 minutes, that's fine. We can split time with somebody else. Just reach out to one of the organizers. We're happy to get you on the schedule.